what it should look like. So your A is a -2, which means it flips upside down, which you have to remember at the end. Your amplitude is 2. Your B is 1, so your period's 2 pi. If you memorize like the parent function, the period is 2 pi. So if you remember your 1/4, your 1/2 is 0, pi over 2, pi, 3 pi over 2, and 2 pi. Obviously, that would help you with time. If you don't remember it, then you got to multiply times 1/4, 1/2, 3/4, and that's where the original ones come from. So that's 0, pi over 2, pi, 3 pi over 2, and then 2 pi. But then there is a horizontal shift or a phase shift here. I have to set that equal to 0, which means my phase shift is a positive pi. So then to each of the ones that I got originally, I'm going to add pi. And I get my ending key points, which are pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. Make sure you make that point, like make sure you know what those are before you draw your axis, because that first key point has to be to the right of the y-axis. It's not starting at the y-axis. So you're starting at pi. Normally you'd go up from there to 2, but because it's negative, we go down to -2, back up to 0, up to +2, and then back down to 0. And then it's a vertical shift up 1. So all those points get shifted up 1. I have like colored pencils tomorrow. I'll put them out so that if you get to the end and you're like, okay, this is my answer, and you have a bunch of shifts going on, you will do your answer in that color so that I know which one you intended to be the final answer. Okay, yep.
Is that for being 2 periods of a positive and you have 1 positive and 1 negative?
But you're doing, no, this is only 1 period.
Wait. Oh, I got it.
Yeah, this is only 1 period. The other ones we can drop on either direction. Yeah. The second one. The second one is cotangent. If it's cotangent, then we set it equal to 0 and to pi. Solve, and you get the middle two asymptotes are x equals pi and x equals 2 pi. Your period was pi because it's pi over b and b was 1. So from the one on the left, you subtract pi, you get 0. To the one on the right, you add pi, you get 3 pi. Those are your 4 asymptotes. Then you find the point halfway between. Those are your zeros. Those also have to be labeled. Then you draw your asymptotes, obviously through the first ones. You plot your x-intercepts where those zeros are. You eyeball, I don't need you to find the exact point. You will not have time. You eyeball the quarter point, the 3/4 point. And because it's cotangent, you go up, left, down, right. So you go up to the A on the left, down to the A on the down to the negative A on the right. And you make your overall curve pass through.
Wait.
Yep.
How do you know which one you add and subtract to?
It's whatever. So if you always do it this way, like visually this, if you do it the way I do it, where you start with the middle two, and you subtract from the left and you add to the right, then it will go in order of what's on your x-axis. So the one that you set equal to 0, you subtract because you're going to go backwards. The one you set equal to pi, which is bigger than 0, you add because you want to go forwards. If you mess that up, though, you just duplicate your asymptote. You'll catch it. It's just a waste of time. But because if I subtract from this one, I get that one. So it's duplicate and you won't have enough. If I add to this one, I get that one. Again, it will duplicate and you won't have enough. Does that make sense? So you subtract from the smaller one, you add to the bigger one. But if they're in, like if you set it up the same way, it will be in that space visually. Subtract from the left, add to the right. Yeah. You have to split the difference between 0 and pi. So in between 0 and pi, halfway between would be pi over 2. In between pi and 2 pi would be 1.5 pi. So 3 pi over 2. It's halfway between your asymptotes. So if you don't see it, like if it's not obvious, then I add these two and divide by 2. So 0 plus pi divided by 2 is pi over 2. That's the point in the middle.
Is that what you're doing at the bottom? Is that what you're doing?
That's in the bottom. That's what these points are. So pi plus 2 pi divided by 2. 3 pi over 2. That's the middle. Then the last one, 2 pi plus 3 pi divided by 2 is 5 pi over 2. That's the asymptotes. So listen. The test is going to literally give you a line for your A, for your period, for your asymptotes, and for your zeros, and then you're going to graph them. So there are points earned for all that stuff. If you're running out of time and you can't find your zeros, do your asymptotes. Pick a spot in the middle and do your curves, okay? But obviously you should have time to do that because that's how you're going to get the full credit. Yeah. Cosine goes up, cotangent goes up, left, down, right, tangent flips. All right, here's the tangent one. Listen, even if you did, so if you didn't finish this, my advice is to make sure you still finish these at home and then double check against, I'm putting this on the video right now, okay? This is the tangent one. So this time your A was negative, which means tangent normally points up to the right, down to the left, but because it's negative, it flipped it, so it takes on the shape of your cotangent. Then your period is pi over 2 because your B is 2. I set 2x minus pi equal to negative pi over 2 and positive pi over 2 because that's what we do with tangent. And I got asymptotes at x equals pi over 4 and x equals 3 pi over 4. Then from the left, we're going to subtract that pi over 2 and I get negative pi over 4. On the right, I'm going to add pi over 2 and I get 5 pi over 4. Those are your asymptotes. Find the point halfway between. Those are your zeros. Your A is 2. It's negative 2, so it's upside down, but the absolute value of that is 2, which means I go to 2 and negative 2. And if it was positive tangent, it would have gone this direction. Because it's negative tangent, it flips, so it goes up, left, and down, right. Again, you're getting a cotangent or a tangent. And then, obviously, if you got sine, you're getting cosecant. If you got cosine, you're getting secant. So you're going to get one of them. This is the last one. So this was cosecant. I graph it as though it's sine. This, again, had a phase shift. So I set that equal to 0. And I got my phase shift as 2 pi. I added the pi, multiplied by 2, and I got the phase shift as 2 pi.
Wait, that's number 4?
Oh, I think you guys have this one. Just kidding. Sorry. I have extra. I just cut them out because we weren't going to finish. All right, questions before we do that unit circle. Questions on anything graphing related.
Tangent.
Is that a question?
Yeah.
So secant means you're graphing cosine. Okay, again, remember you're getting one of each of them. So the A is 3, which is your amplitude. The B is pi over 2. That makes your period 4. Find the points where it crosses through the x-axis. Find your asymptotes. And then this one was a shift down 1. Shift it, then graph it. So let me just stress this to you that this is 3 questions of your test. You have to do the rest of that review. These graphs are 3 questions, okay? So if you did not finish that review last night, you have your work cut out for you today. You have to know how to apply the unit circle. You have to know how to do your right triangle trig. You have to know the cofunctions and the even odd, like all the stuff that we went over yesterday is in the review that is the PDF. You are not done with your work for today, folks, especially because it was like crickets when I was asking the review questions, which is very frightening. You will, again, start with the calculator part. There's 2 word problems in there, and then your inverse and your regular trig functions using the calculator, and then you'll switch to the other stuff. Yeah.
For 4-7, is it just like using the unit circle?
No, remember those 3 things at the end of that last slide? Unit circle, it's calculator, and it's using triangles.
But the ones where it just has like arc